So, problem 3.3. Well, let's just start from one end and work all the way down. So what we have here, first in A, is we want to find the probability that an X-year-old and here the X is that a 30-year-old survives age 40. So the 10 comes in the sense that we want to look at the probability that a 30-year-old survives the next 10 years. So this is given by 10p30 equal to, and since what we have been given is the mortality rate, we will operate using the mortality rate and using this formula here. So it is given by e to the minus integral from 0 to t of our intensity or mortality rate, 0.004 ds. And note, I don't need to take the 30 into account here because, well, the mortality rate is constant no matter whatever I plug in. However, I do need to take the t up here into account, so I can't just write t up there. What I need to write is I need to plug in the value of t, which in my case is 10. So this thing over on this side is what I need to plug in here. Okay, 10. And what I have here is that this is equal to e to the minus 0.04 because 0.04 is the value of this integral evaluated, and you can figure out the numerical value of that yourself. So now let's go on to B, where we consider the probability, and this is a rather somber probability, but it is the probability that a 15-year-old dies within 5 years. Oh, depressing stuff here. So this is given by 5q15. So the probability that a 15-year-old dies before this person turns 20. This is equal to, as I mentioned before, this is equal to 1 minus the probability of conditional survival, which is denoted by p, so 5p15, and we have the conditional survival probability again using the formula over here, and that is e to the minus 0 to 5, and again we just plug in the constant mortality rate of 0.004 because it is constant. It's not a very pedagogical example, but we'll make do. So here this is equal to 1 minus e to the minus 0.02. And you can, once again, figure out this numerical value for yourself. And last but not least, we have C, where we want to find the age X. So find X such that a newborn has probability 90 of surviving age X. So as we mentioned earlier, that corresponds to finding X such that the probability of a newborn surviving the next X years is equal to 0.9. Now, we do this by writing up the expression of the probability of a newborn surviving the next X years, and then we isolate X in this. So xp0 is given by e to the minus integral from 0 up to x, because this is the number of years we want to have our cute little baby survive. And again, we just plug in the constant mortality rate here. And this is equal to e to the minus 0.004x. So this is equal to 0.9 if and only if, let's see, what can I do? I can take the log on both sides, right? So if and only if 0.004x is equal to the minus log of 0.9. And if I just divide by 0.004 on both sides, then I think I'll get x. So what do I have that x is? X is equal to, so hence 90% of all newborns live past age, well, I should really calculate this. So if you just wait a moment, I'll go on Google and do this calculation. So now I am back from Google with an extremely cheery number. Seems like 90% of all newborns in this universe anyways survives past age 26.3. Yay! So this was a quick exercise. Not much to say about this exercise other than use it to become familiar with the notation in chapter 3. And also, if the world were so nice, everything would be pretty nice. So calculate the numerical answers for A and B on your own, and see you in the next exercise.